Welcome to 5-Minute Math. This is Carrie Rhinehart. Today I'm going to be looking at multiplying and dividing rational expressions. If you're following along in the book, this is from Algebra 1, Unit 6, Lesson 6. So what we're doing today is very similar to simplifying rational expressions. You just have more polynomials to factor and more excluded values to search for. And also don't forget when you're dividing fractions to keep it, change it, flip it. So if we have a over b divided by c over d, we need to keep the first fraction, so a over b, change to multiplying, and then flip that second fraction. And then we can solve it just like a multiplication problem. So again, if you're dividing fractions, you need to keep it, change it, flip it first. All right, so let's look at an example. Let's say that I've got x squared minus 5x minus 14 over 3x plus 9 times x squared minus 9 over 2x minus 4. Okay, so just like with simplifying, the first thing I'm going to do is just factor everything. Okay, so this x squared minus 5x minus 14, I can do the asterisk with. I get 1 times negative 14, which is negative 14 on top. B is negative 5, and then x and x. In this case, negative 7 and 2 are going to work because negative 7 times 2 is negative 14, and negative 7 plus 2 is negative 5. So this factors into x minus 7 times x plus 2 over. Now next, right here, this 3x plus 9, I can factor out a 3. So if I factor out a 3 and divide both of those by 3, I'm left with x plus 3 times, now this x squared minus 9, that is a difference of two squares. So that's going to factor into x plus 3 times x minus 3. And then this last one, 2x minus 4, again, I can factor out a GCF of 2. And if I divide both of those by 2, I get x minus 2. All right, now just keep in mind, if this was a division problem, the first thing you would do would be keep it, change it, flip it. And then it would be a multiplication problem, and you would start factoring like I just did. Now I need to check for excluded values by setting any variable factor equal to zero, as long as it's in the denominator. So I need to set that x plus 3 equal to 0, which is going to be x equals negative 3. That's one of my excluded values. And I need to do the x minus 2 equal to 0. So that's going to give me positive 2 for another excluded value. Again, only set the factors in the denominator that have a variable in them equal to 0. That's all you have to worry about. And now we can just cancel. As long as there's one factor on top and one factor on bottom that are exactly the same, even if they're not in the same exact fraction. Okay, with multiplying, it doesn't matter. As long as you have one in top, one in bottom, you can cancel them. So I see x plus 3 and an x plus 3 there. And I don't see any other common factors. I see an x plus 2 and an x minus 2, but those are not exactly the same, so I can't cancel them. So I just need to rewrite everything as one fraction. So I've got x minus 7 and x plus 2, and I have an x minus 3 left over here. Now it's just all one fraction. In the denominator, I have 3 times 2, which is 6. And I also have an x minus 2. And so this is your final answer. And these up here, this negative 3 and this 2, those are excluded values. So I write x cannot equal negative 3 and 2. Because if they do, we'd end up with 0 in the denominator. And we don't want that because that would be undefined.